Hey guys, today we're chatting about rational expressions still, and today we're focusing on addition and subtraction of rational expressions. So we're first going to start off with uh, a fraction problem. We're going to add 4/7 plus 5/21. We know that we're going to need a common denominator. So the common denominator of 7 and 21 will be 21, which means that we need to multiply our left fraction by 3/3. So remember, we multiply straight across. This would then give us 12/21 plus 5/21. And now that we have that common denominator, we just need to add our numerators together. So 12 plus 5 gives us 17/21. And then we just verify, can I reduce that fraction? In this particular case, we cannot, but if we were, we would want to do that. So now let's move on to a rational expression. Remember, a rational expression is when I have a polynomial divided by another polynomial, and we're going to add them together. Just like regular fractions, we need to have a common denominator in order to add them together. In this particular case, it looks like we already have that common denominator. So since we have that common denominator, we're going to go ahead and write our common denominator and add our numerators together. So x plus 2x would give us 3x, and 0 on the left plus a positive 1 gives us 1. We then ask ourselves, can we factor the numerator? And in this particular case, we cannot. So if we cannot factor our numerator, I cannot simplify it with anything in my denominator, so we know we're done. Another example. Here it looks like I have a common denominator, except this time we're subtracting. We have to be super careful when we're subtracting, guys. So pay very close attention to our signs when we're subtracting and talk yourself through it. So since we have that common denominator, we're going to write our answer over that common denominator. So I'm going to take 8x minus 6x. So I'm taking 8x minus 6x, which gives me 2x. And now I'm going to take 3 minus a positive 10. So 3 minus 10 would give me -7. Again, can we factor that numerator? No. And since I can't factor and there's nothing common in our numerator and denominator, we can stop right here because we can't simplify any way further. The problem comes in, guys, when we do not have a common denominator and we have to make a common denominator, such as the one here. So I've got 10 over 3a squared b cubed plus 8 over ab squared. So I'm going to first look at my number, 3 and 1. The common denominator between 3 and 1 would need to be 3. Also, when I look at my letters, I have 2 A's on the left and I have only 1 A here. So I would need to have another A on the right side, so building to A squared, in order to have them be the same, because I can't take away anything from the left, but I can multiply by something on the right. So far we've got 3a squared, and then notice my b's. I've got 3 b's on the left and 2 b's on the right. I'm going to need to build to 3. So we're going to build to the larger amount here so that we can all have the same thing. So notice that the left fraction already has our common denominator, so we don't need to multiply our left fraction by anything. But what we do need to multiply is our right fraction by something so that we can build to that least common denominator of 3a squared b cubed. So I need to multiply by 3. I already have 1a, but I need to multiply by another a. I already have 2 b's, but I need one more b to build to b cubed. Then what I can do is multiply my right side numerators together so that I can simplify before adding. So when I take 8 times 3, we get 24, and A, and then with our B. Notice nothing on the left changed. Now we can add across. Notice that I cannot add 10 plus 24AB to make one cohesive monomial, but what we can do is still keep them separate and have it over one fraction with that common denominator. So 10 plus 24AB over 3a squared b cubed, that one denominator making one fraction. Don't get caught up trying to add 10 plus 24ab and making it some crazy 34ab that I've seen before. So just keep them separate there. It's okay the way it is. Then we ask, can you factor the numerator? And I see we have a greatest common factor in our numerator of 2. So if I factor my numerator and divide each piece by 2, we end up with 5 plus 12ab. So then our next question is, can we simplify the expression? So notice I can't simplify 2 with our 3 here, and this certainly doesn't have a pairing in the denominator. So at this point we can stop. We've combined our fractions into one. We tried to simplify, we just couldn't. Another example, I've got 3 over x plus 7 plus 8 over x squared minus 49. Sometimes we have to factor before we can combine or add or subtract. So I see on the right-hand side that I can factor x squared minus 49 because it is a difference of perfect squares. So x squared minus 49 is the same as x plus 7 and x minus 7. We now need to identify our common denominator. So notice the left and the right both have an x plus 7, but we also need to take into consideration this x minus 7. So our common denominator is going to be the x plus 7, which is from here and here, but we also need to have the x minus 7. So now when I compare my fractions to the common denominator, I see that my left side over here is only missing the x minus 7. So I'm going to multiply the left fraction by x minus 7 over x minus 7. So at this point, I'm going to need to distribute my 3 across here so that I can simplify my parentheses. So that will give us 3x minus 21 over x minus 7, x plus 7. Added 2, notice we didn't change anything on the right because it already had the denominator. Notice now that they both have the x plus 7s, they both have the x minus 7s, so now we can go ahead and combine our numerators. So I have 3x plus 0x's giving me just regular 3x, and negative 21 plus 8 is negative 13. Can we factor our numerator? No, we don't have a GCF, so since we can't factor, we're done with simplifying and combining. Our sixth example, I've got 4y over y plus 1 minus y over y minus 1. Notice here that we're not able to factor our denominators. They're just individually different. And I can't force something by adding 2 to both sides on the right here because negative 1 plus 2 is positive 1. We can't do that. We have to multiply by something. So my common denominator is going to be each binomial. It's going to be y plus 1 and y minus 1, which means that each side of my fractions are going to be multiplied by something. I'm going to multiply our left fraction by y minus 1 over y minus 1, and my right fraction by y plus 1 over y plus 1. So by doing so then, I can now distribute each one of my numerators. So 4y times y is 4y squared. 4y times negative 1 is negative 4y. Minus, now we'll do the right-hand side, y times y is y squared, and y times 1 is 1y. Okay, now they each have the y plus 1 and the y minus 1, so we can go ahead and subtract our numerators. Again, in subtraction, be very careful, so talk your way through it. So I've got 4y squared minus 1y squared. Well, that gives us 3y squared. And if I have negative 4y minus a positive 1y, we are now 5y in the whole. So 3y squared minus 5y. Our next question, since I've combined them together, is can we factor the numerator? I see they both have a y, so I'm going to factor out the greatest common factor. That would give me y times 3y minus 5. The follow-up question to that is, can we simplify the rational expression now? Notice we don't have any common binomials, so we cannot cancel anything out. So at this point, we're done. Our next example, very similar to the previous one, I have 6 over 5a plus 5 over 3a plus 2. Notice that our denominators are completely different, so our common denominator has to be each piece, 5a and 3a plus 2, because they are completely different from one another. At this point, then I'm going to multiply my left fraction by the 3a plus 2 over 3a plus 2, because that is the piece it's missing from the common denominator. And on the right side, I'm going to multiply by 5a over 5a, because that piece is what's missing on that side. I can go ahead and distribute then, so we can start combining. So 6 times 3a gives us 18a, and 6 times 2 gives us 12, plus 5 times 5a is 25a. Notice all I did was rearrange them so they kind of match the bottom. We can do that in multiplication. Now we can add things together. So 18a plus 25a gives us 43a, and 12 plus 0 gives us 12. Again, we ask the question, can we factor the numerator? In this case, we cannot, so we know we are done since we can't simplify. We have 3 over x squared minus 5x plus 8. Subtract x plus 2 over x squared minus 6x plus 8. We have all kinds of crazy things here, but the very first thing I'm going to do is factor our denominators so that we can start comparing them and finding our least common denominator. So to factor, on the left, I want to find two numbers that multiply to 6 but add to -5. So -3 and -2, we can jump to our factored form because we don't have a number in front of x squared. Similarly, we want to find two numbers that multiply to 8 and add to -6. -4 and -2 work. Again, we can jump to our factored form because nothing is in front of x squared. Now we can find the common denominator. So the common denominator is going to have x minus 3 and x minus 2. Our common denominator doesn't quite have x minus 4, so we need to have x minus 4 as well. But notice I already have the x minus 2 down here, so I don't need to write it again since it's already included one time. So now when I compare my least common denominator to each fraction, notice the left side needs the x minus 4, and our right side needs the x minus 3. So I'm going to multiply the left side by x minus 4 over x minus 4, and our right side by x minus 3 over x minus 3. I'll go ahead and distribute, giving us 3x minus 12 minus, and we'll have to FOIL the right-hand side, so x times x is x squared, x times -3 is -3x, 2 times x is 2x, and 2 times -3 is -6. I can combine like terms, so -3x plus 2x gives us -1x. And now we can combine our numerators. So notice I have 0x squared minus 1x squared. So 0x squared minus 1x squared is -x squared. I have 3x minus a -1, giving me positive 4x, because a negative times a negative is a positive. And I have -12 minus a -6, which is -12 plus 6, which is -6. Can we factor the numerator? I can. I'm going to factor out a -1. So by factoring out a -1 turns that first term into a positive, switching the remaining terms. But now there's nothing I can do to multiply to 6 and add to -4. So even though we could factor, we can't simplify past this point. So this whole piece is our final answer.